Let's start with xerostomia. That means dry mouth. So, by definition, it is decreasement of saliva secretion. That means hyposalivation, and that means it will lose all the functions that saliva does. So, saliva has five key roles: lubrication, moisturizing, cleansing, buffering, immunity, and acting as a solvent for taste. So, if we lose the lubrication ability, that means if there's no enough mucin to trap water and make the football smooth, it causes dysphagia. That means it won't be able to form the balls. And if we lose the moisture, it will be difficult for us to speak. And also, it does cleansing and buffering. Without the buffers, it will increase the probability or risk for dental caries. And immunity, it has immunoglobulins and IgA and lysozyme. So without that, it will increase the infections. The microbes will grow more. And also it is a solvent for taste. So it dissolves and then without it, you'll lose the taste as well. So dry mouth is basically dry, like dirty teeth, dry food, dead defense, dull taste, difficulty to speak. So all five things are from D. And about gastrophysiology, when we see the food, it exactly starts secretion of gastric acid. This is called the cephalic phase. So the stimulus is like sight of food or smelling or whatever thing, and it goes via the brain and then vagus nerve. So then acetylcholine is released. So when acetylcholine is released, it binds to the muscarinic receptors and it will increase the gastric acid secretion. So normal saliva. What you must know before pathology is it contains 99% of water, mucin, electrolytes like bicarbonate, potassium, sodium, chlorine, and the enzymes, lingual lipase and salivary amylase, and defense proteins like secretory IgA, lysozyme, lactoferrin, and peroxidase. So saliva is regulated by autonomic nervous system. So parasympathetic, cranial nerve 7 and 9, that means facial nerve, and the glossopharyngeal, that will increase the watery saliva, while the sympathetic one increases thick protein-rich saliva. So anticholinergic or atropine will block the parasympathetic, that causes xerostomia. So in xerostomia, the thing that happens is the five physiological roles of saliva will be lost. So it will cause dysphagia. That means no mucin, no lubrication, food bolus is not formed. So when there's no lubrication, friction increases. So swallowing becomes mechanically difficult. And also there will be speech difficulties. So tongue, oral mucosa, they need moisture. So dry spaces, surfaces will increase the friction and then it will it will make it difficult for us to speak due to poor articulation. And dental problems, normal saliva versus bacteria neutralizes acid that is made by bacteria as it does bicarbonate and provides calcium to blast for remineralization. In xerostomia, the acid persists, enamel demineralization, and then it will cause dental problems. And also infections, loss of IgA, lysozyme, and lactoferrin. So, as there's no lactoferrin, bacteria will get iron, while if there's no lysozyme, no bacterial lysis, when there's no IgA, no immune explosion. And also, it increases the fungal plus bacterial infection. So lot of taste. Taste requires chemical dissolving in saliva, diffuses into the taste hole, and then stimulating the receptor. So when there's no saliva, the chemicals can't dissolve. So this is called hypogeusia. And then we come to the cephalic phase. So it is the trigger is sight, smell, or thought of food. So the neural pathway is cortex, hypothalamus, medulla, dorsal motor nucleus of vagus, and then vagus nerve. So there are three parallel pathways in this. Direct pathway, which is neurokine, acetylcholine is released and binds to the muscarinic receptors in the parietal cells. M3 that activates the potassium and proton ADPase. Hormonal, vagus nerve will release GRP and it will affect G cells and then it will release gastrin and it goes to the blood and binds to CCKB receptors and it will increase the acid secretion. And then there's this paracrine, which is acetylcholine and gastrin will go and uh, stimulate ECL cells, enterocorfin, homophene-like cells that releases histamine, and histamine goes and binds to H2 receptors in the parietal cells to increase acid secretion. So, critical concept is here potential. So, these three don't act independently. Together, exponential increase in acid level. That's why H2 blockers that blocks histamine will have a huge effect because histamine is a huge potent increasement of gastric acid secretion. And then there's accommodation. That means receptor relaxation. So problem is when you eat food, stomach go on stir food without increasing the pressure. If if the stomach couldn't increase pressure, that means when you eat something, it will it will be painful and also you will feel full with less amount of food. So due to that, it expands so that you don't have to keep on eating. Otherwise, you will have to keep on eating if you can't eat enough food uh, at a given time. So for that, it has to store food. It should act as a storage because we had to do other stuff as well, right? We can't be eating. So the mechanism is vagal reflex. So if you think about it stepwise. So first we swallow. So the gastric stretching happens, and the afferent vehicles will tell it to the brain uh, will send the signal. So this is known as the vagovagal reflex. So here the neurotransmitters are nitric oxide, that smooth muscle relaxation, and a vasoactive intestinal peptide that will enhance the relaxation. So the effect is the fundus and also the proximal body, they relax. So the volume of this increases up to 1 to 1.5 liters. So the pressure stays constant. So that's why you can feel like you can eat a lot. So otherwise, if the pressure increases, like when you eat one or two, um, like when you get one or two chips or anything, you'll feel that your stomach is full. But it won't happen like that because stomach will increase its size and the volume. So the pressure won't increase as such. So there's a clinical link as well. Lots of this cause early fullness. So in some gastric disorders, this happens. And then there's this gastrocolic reflex. So normally when food is there, stomach distension happens. So it happens due to autonomic reflexes and hormones. Gastrin may contribute and enteric nervous system. So the effect is such that the colon will increase peristalsis and increase mass movements. So finally, the outcome will be rectum will get filled When rectum fills, the stretch receptors in that causes defecation reflex, the urge to uh, put out the fetus. So the clinical point here is this is strong in infants. And about dysphagia, so following has three phases: oral, pharyngeal, and esophageal. So oral is voluntary, pharyngeal is reflex, esophageal is peristalsis. So dysphagia can be due to a tumor, a web, or any kind of a obstruction. So it mechanism is that it physically narrows the lumen. So first solids will get affected and then only the liquids will get affected. But if it is a motor dysphagia, that means due to eclasia, stroke, or Parkinson's, the mechanism is that failed peristalsis or splinter relaxation. So that means from the beginning itself, solids, liquids will get obstructed, not like in structural dysphagia, because that one is narrowing, so liquids can move through, while in motor dysphagia, all the things will get obstructed. So if they ask you in a viva, if the lumen is narrow, that means solids gets affected first. If the movement is defective, everything will get affected. And there's something else called Plummer-Wilson syndrome. So yeah, the mechanism is the thing that is important. It happens due to iron deficiency. So in this iron deficiency, epithelial atrophy happens. So it will form esophageal webs. So there's a triad actually. The thing is iron deficiency, anemia, dysphagia, and esophageal webs. Additionally, glossitis, glossitis and risk of squamous cell carcinoma, that means cancer, will also occur. And about regulation of this GIT, there are three layers of control system. Three layers: intrinsic system, ENS, so enteric nervous system. So this first one is mesenteric, that is called oak patch, between the muscle layers that controls motility. Submucosal is mesonous, that controls secretion and blood flow. And if we talk about the hormonal control, the hormone gastrin, uh, it gets stimulated by protein and vagus nerve, and it will increase acid secretion, and hormone cholecystokinin will get stimulated by fat and amino acids, and it will increase enzyme secretion from the pancreas and also reduce the gastric empty. And secretin will get stimulated by acid, and it will cause pancreas to release HCO3 minus to neutralize the acidity. And the IP gets stimulated by glucose and fat, which will increase uh, insulin. And if we talk about paracrine, histamine will increase acid, somatostatin is an inhibitor. So then, if we talk about the motility, uh, they are generated by the waves are generated by pacemaker cells. So so that means they do not cause contraction alone. They need action potential. So there are few patterns of this: segmentation, peristalsis, and MMC. So segmentation means mix in movement. There's no forward progression. Peristalsis means oral contraction and anal relaxation. That means you should contract from one side and relax from other side to allow that food bolus to pass through. Otherwise, if you contract from both sides, it won't. It will get stuck instead. And this is driven by the enteric nervous system. And MMC, the fasting state, is it happens every 90 minutes and it clears the bacteria and debris. This is controlled by motility. And gastric acid secretion, happens in parallel cells. Carbon dioxide and water will produce H2CO3 that will break down to H plus and HCO3 minus. And this H plus will go to the lumen via H plus Ka plus ATPase. Alkaline tide HCO3 minus enters plant after meals. If we think about the phases of the digestion, cephalic phase, the stimulus is central nervous system, and it happens like 30% of the, and gastric phase is stimulus is distension, it is like 60%, and intestinal is merely inhibitory. And if we talk about the absorption, carbohydrates, glucose and galactose are mainly absorbed, mainly transported via uh, SGLT1 transport. That means sodium plus co-transport. Fructose via GLUT5 and protein, they are absorbed as amino acid, di or tripeptides. While lipids, they are not water soluble, they need bile salts to form muscles, absorbed as chylomicrons and the lymph. And vitamin B12, they need this intrinsic factor absorbed in the terminal ilia. And achalasia occurs when there's less nitric oxide and VIP, vasoactive intestinal peptide, so that the lower esophageal sphincter doesn't relax. Dysphagia uh, will occur due to achalasia. That means in here, as it doesn't relax, will affect both solids and liquids uh, to the equal extent because there's no narrowing. If there's narrowing, the liquids can pass through, but as it is the sphincter not relaxing, both liquids and solids will get affected. And GERD, that is a reflux, that means the lower esophageal sphincter is not uh, working properly, that will cause acid reflux. So, uh, if you think about the complete physiology, saliva formation has two steps. Actinous secretion, that means primary saliva produced by actinous cells. The composition is isotonic, similar to plasma. Sodium, chloride, water, enzymes. So mechanism is that chloride minus is active, secreted sodium plus follows paracellular, and water follows by osmosis. So that means that's basically isotonic. And then ductal modification is the one that makes it different from the plasma. So this occurs in the striated ducts. So these ducts are water impermeable due to tight junctions. So sodium and chloride are reabsorbed while potassium and HCO3 minus are secreted. So that means the final saliva becomes hypotonic. So this is whole thing is entirely under autonomic control. That means parasympathetic one is the dominant, which happens via facial and glypharyngeal. So the neurotransmitter is acetylcholine, acting via muscarinic 3 receptor. The effect is that watery saliva increases, blood flow increases via bradykinin. Sympathetic happens via beta adrenergic receptors. It produces thick protein-rich saliva. Xerostomia is loss of saliva, loss of mechanical plus chemical. So, and also immune functions. So dysphagia can be uh, two types, and normal, that means difficulty in swallowing. So normal mucin reduces friction. Bolus is formed, but due to xerostomia, no lubrication, friction increases, impaired swallowing, and also it will be painful. And also, normal saliva has buffering. HCO3 minus neutralized bacterial acid and remineralization via calcium 2 plus and phosphate cleansing will remove the food debris, but due to xerostomia, acidic pH persists and it will cause enamel breakdown. And if we talk about the oral infections, So loss of IgA and lysozyme and lactoferrin. So that means lactoferrin will allow bacteria to access iron, while lysozyme will not kill bacteria walls. And IgA, that means there's no immune exclusion. So it will increase uh, the risk of candida and bacteria uh, growing, proliferation, and loss of taste because saliva is needed for this taste chemicals to dissolve and diffuse. Without saliva, there's no receptor stimulation. So another thing is in cephalic cells, uh, the vagal different uh, effects are first afferent pathways, cortex, and then it goes to the hypothalamus and the medulla and dorsal motor nucleus of vagus. And vagal efferent effects are direct pathway is that acetylcholine goes and binds to the muscarinic receptors and then it will increase the intracellular calcium 2 plus. And gastrin pathway is that it releases GRP, not acetylcholine in here. In gastrin, it releases GRP, G cells, and then gastrin, and it will go to the bloodstream and um, activate parietal cell. Histamine pathway is the most important one and the most like it will increase gastric secretion more. So it happens as acetylcholine and gastrin go and bind to ECL cells, and histamine is released, which will bind to H2 receptors in the parietal cells to increase CAMP. So acetylcholine and gastrin, of course, react like they increase this production via calcium 2 plus, while histamine works via CAMP. So calcium 2 plus and CAMP together will cause massive acid secretion. So if you think clinically, H2 blockers block histamine, so it decreases acid strongly, while uh, proton pump inhibitor block the final step. That means the proton pump. So then the gastric accommodation is a functional necessity. So if stomach didn't relax, even small food can cause increasing pressure and even vomiting. But the reflex arm, that means the afferent limb, the stretch receptors will tell vagus and go to the brainstem, and then efferent limb, vagus will send inhibitor neurons. So the nitric oxide activates CGMP causes relaxation and VIP causes smooth muscle relaxation. So the region-specific effect is that fundus proximal body relaxed and distal stomach remains active because it should do grinding and uh, loss of this causes early fullness. So this loss of it is seen in functional dyspepsia. And about the gastrocolic reflex, so the trigger is the gastric distension after meal. So the pathways are enteric nervous system, autonomic, parasympathetic, that means parasympathetic, or hormonal contribution, that means gastric. So the colonic response is such that it increases the mass movement, strong peristaltic, usually 1 to 3 times a day. So the final outcome will be rectal distension and it will also affect stretch receptors and then spinal defecation reflex and then conscious urge to pass stool. And dysphagia is normal peristalsis is controlled by enteric nervous system and vagus. So that's a sequential contraction. Structural dysphagia is physically narrowing resistance to flow. So that means it will affect solids more than liquids. But moderate dysphagia, that means failed peristalsis or splinter dysfunction. As an example, achalasia. This causes loss of inhibited neurons. So there's no nitric oxide and VIP. So low esophageal splinter fails to relax. So the result is food cannot pass and both solids and liquids both get affected in moderate dysphagia. And the Plummer Wilson syndrome is making a So here the iron deficiency causes epithelial atrophy, formation of mucosal wells. So why this failure happens in this Framar syndrome? Because web partially obstruct the lumen, and also there's a cancer risk because chronic epithelial damage, uh, and then dysplasia, also cancer risk as well, carcinomas. So about GIT regulation, enteric system, intrinsic control, magnetic flexus controls the motility, submucosal controls secretion and blood flow. So parasympathetic, extrinsic one is parasympathetic and sympathetic. Parasympathetic increase the motility and secretion, while sympathetic decrease both. So the hormone control, gastrin get triggered by protein and it will increase acid. Cholecystokin will get triggered by fat, it will increase enzyme. Acecretin will get triggered by acid and it will increase bicarbonate secretion. GIP will get triggered by glucose and it will increase insulin. And about motility, slow waves, also called BER, generated by intestinal cells of Kachal, they set the rhythm, not the force. Action potential occur when slow wave plus stimuli. If the threshold is reached, then it will cause calcium 2 plus influx and then contraction. And there are different patterns. Segmentation means mixing that enhances the absorption. Peristalsis means uh, enteric nervous system reflex. Oral site contraction due to acetylcholine and substance P. Anal site relaxation due to nitric oxide and BIP. And MMC occurs during fasting and it clears bacteria. And gastric acid, parietal cell process carbon dioxide and water. So it will form carbonic anhydrase and then, carbonic anhydrase is the enzyme. It will form bicarbonate and H plus goes to the lumen via proton pump and HCO3 minus possesses alkaline type. So the protection mechanisms of this from HCl are mucous barrier, bicarbonate secretion and tight junctions. And if you talk about the absorption mechanism, carbohydrates are absorbed via SGLT1, glucose plus sodium, and fructose via GLUT5. Lipids form muscles and enter the enterocyte and reassembles as chylomicrons and then leaves. B12 needs the intrinsic factor and absorbed into the ileum. So achalasia is loss of inhibitor neurons. So lower esophageal sphincter stays contracted and GERD means lower esophageal sphincter is not working properly. So it will cause reflux. And Solinger Ellison means gastronoma, that means uh, extreme acid. Solinger Ellison. And Hertzsprung means no enteric nervous system, that means no relaxation. So there's functional obstruction. And damping syndrome means rapid gastric emptying, osmotic fluid shift that causes diarrhea. So we think this is controlled by enteric nervous system and autonomic and hormones, and movement occurs by segmentation, peristalsis, and MMC, and the secretion and absorption via acid, enzymes, and transport. So if you think it as a story, it will be easier for you to understand. So the meal begins in the brain actually. So cephalic phase. You haven't even eaten it. You see the food, you smell it, maybe even imagine it. That sensory input goes to the cortex and then hypothalamus and then medulla dorsal motor nucleus of vagus. Now the vagus nerve activates the gut film before the food arrives. So before the food arrives, there are three parallel signals that are sent. Direct neural stimulation that release vagus raised acetylcholine binds to M3 receptors in the parietal cells, which will increase calcium 2 plus and that will increase H plus and K plus ATPase activity so that H plus is secreted to form gastric acid. And hormonal pathway is vagus release GRP that will stimulate T cells to release gastrin and it will go to the bloodstream and act on CCKB receptors. Paracrine pathway is that Acetylcholine and gastrin both go and stimulate ECL enterochronophil-like cells. They release histamine that will go and bind to H2 receptors in the parietal cells, and that will increase CAMP. So remember, histamine is the only one that releases works via CAMP, while acetylcholine and gastrin both increase calcium to blood. So it is easy to remember. Histamine is the largest word here, longest word here. So CAMP is the longest thing here. So histamine is acting as CAMP. So together the acid secretion becomes massive potentiation. So blocking histamine, H2 blockers major reduction in calcium secretion, and blocking proton pump PPI means total shutdown. So when food enters the mouth, saliva takes over. That means salivation increases. So saliva is made by the senile cells that produce isotonic fluid, and duct cells modify it by reabsorbing sodium and chlorine and secreting potassium and HCO3. So and also water cannot flow. So this makes final saliva hypotonic. So saliva is essential because it is needed for the bolus formation, and mucin will reduce friction and allow solvent and chemical digestion. Amylase begins starch dilation uh, of 1,4-glycosidic bonds, taline, and protection via IgA lysozymes and HCO3. Taste is also due to saliva. They dissolve in saliva. So xerostomia means no lubrication, no buffering, no immunity, no solvent. So one defect, multiple syndromes. What are syndromes? Dysphagia and dentary problems, infections, loss of taste, and swallowing is like a precisely timed event. So food is a bolus, and swallowing has three phases: oral, pharyngeal, and esophageal. So oral one, tongue pushes the bolus, and pharyngeal one is a reflex suction. Uh, that soft palate closes the nasopharynx and epiglottis closes the airway. Breathing stops briefly. And esophageal means peristalsis begins. So esophagus can get obstructed. So normally it is a coordinated peristalsis, but and also the lower esophagus sphincter relaxes accordingly via s- nitric oxide and VIP. So if the structure is blocked due to tumor or something, the lumen narrows. So the solids will get affected first and then the liquids. So if the model is defective, both will get affected from start. There's no peristalsis and also lower esophagus sphincter doesn't relax. And also stomach receives food but it doesn't resist because the stretch receptors will tell vagus and then brainstem, and then vagus efferent will release nitric oxide and VIP. So fundus reactors can hold 1 to 1.5 liters and pressure remains constant. And also stomach now processes food by acid secretion via proton pump and alkaline diet. So protection against acids are due to mucous barrier, bicarbonate layer and tight junctions. So small intestine is a dilation and absorption hub where motility types are their segmentation, peristalsis, and MMC. MMC happens during fasting. Segmentation means mixing and no forward movement. Hormone secretions are CCK is released due to fat. It will increase pancreatic enzyme secretion, gallbladder contraction, and decrease gastric empty. Secretin will uh, increase bicarbonate while GIP will increase insulin.